Welcome all to today's lecture. Myself, Assistant Professor Tukur Gupta from Ajay Kumar Garg Engineering College, Ghaziabad. As you all know, that I am covering the syllabus of microprocessor and microcontroller subject being taught in 5th semester with the subject code KEC 502. I am covering Unit 1 and today in Unit 1 I will cover 8085 instruction set. So first of all, I'll introduce you to the summary of the instruction set of 8085 and then I'll discuss data transfer instructions. So first of all, what we understand by instruction set? An instruction is a binary pattern designed inside a microprocessor to perform a specific function. The entire group of instructions that a microprocessor supports, that is termed as instruction set. So we all know that instructions are like English-like language words, and the purpose of all the instructions are different according to the requirement. Like some instructions are used to transfer the data, to copy the data. Some instructions are used to perform arithmetic and logical operations. Some are used to perform the branch operations. Since 8085 is an 8-bit device, so it can support up to 2 raised to power 8, that is 256 instructions. However, 8085 only uses 246 combinations that represent a total of 74 instructions. So as we all are aware that each instruction has two parts. The first part is the task or operation to be performed. This part is called the opcode, or we can say operation code. So in short, we call it opcode. The second part is the data to be operated on, and this part is called the operand. So on the data on which the operations are performed, it is termed as operand. So every instruction is having these two parts essentially. The one is opcode and the another is operand. In certain cases, the operand is not specifically given in the instruction, it is understood automatically. We will see in further lectures what I want to say. So, what is the instruction size? Depending upon the operand type, we have different types of instruction sizes. Like the instruction can cover one byte also, it can cover 2 bytes also, and it can take 3 bytes also. So, depending on the operand size type, the instruction may have different sizes. It will occupy a different number of memory bytes. Typically, all instructions occupy 1 byte only. The exception is any instruction that contains immediate data or memory address. So, when the immediate data or memory address is given in the instruction, then it will take more number of memory bytes. So, instructions that include immediate data use 2 bytes, one for the opcode and the other for the 8-bit data. Instructions that include a memory address occupy 3 bytes, one for the opcode, other 2 for the 16-bit address. So, in this way, different types of instructions will take different number of memory bytes depending upon the operands given in the instruction. So, how are the 8085 instructions classified? So, to understand all the 74 instructions associated with 8085, we have to understand the categories into which these instructions have been divided. So, broadly speaking, 8085 instructions are divided into 5 types: data transfer instructions, arithmetic instructions, logical instructions, branching instructions, and machine control instructions. So when we talk about the data transfer instructions, we mean those instructions in which some data is moved or copied from one location to another. It can be a register, it can be the memory location also. Under arithmetic instructions, these instructions are associated with the arithmetic operations like addition, subtraction, then different types of additions and different types of subtractions. In the logical instructions, we deal with the ANDing, ORing, XORing, and branching instructions, we talk about jump, call. So these instructions are covered. In the machine control instructions, These are the different types of instructions we will see in the further lectures. So first category we will cover today, that is the data transfer instructions. So the most important instruction in this category is move. The operands it can take is RD and RS, means destination register and source register. M denotes the memory location pointed to by the contents of HL register pair. RS is the source register, RD is the destination register, and M again is the memory location pointed to by the HL register pair. What will this instruction do? It will copy the source, the contents of the source to the destination. So this instruction copies the contents of source register into destination register. Contents of source register are not altered. This we have to note. The contents of source registers are not altered, means the contents are not actually moved, they are actually copied. If one of the operands is a memory location, then its location is specified by the contents of HL register pair. So in this way this instruction operates. Examples are move B, C. It means the contents of C register are copied to the B register, and in this move B, M means the contents of the memory location pointed to by the HL register pair are copied to the B register. Let's move on to another instruction in this category. Again, this is also a copy instructions, but it will copy the immediate data. The I over here denotes this here denotes that. So these type of instructions are identified by the letter I in the instruction. It means the immediate data. So operands are destination register and data, memory location and data. So the immediate data given in the instruction is copied to the source. Destination. Destination can be a register also or a memory location. Like it is here written here, 8-bit data is stored in the destination register or the memory. If the operand is the memory location, its location is specified by the contents of HL register. Examples are MVI B, 57H, MVI M, 57H. Means according to this instruction, B register will hold the value 57, and memory location means the HL pair contents will point to this memory location and it will hold the value 75 or 57H. So this instruction will write the immediate data into the destination register or the memory location. Another instruction in this category is LDA, that is load the accumulator. We can understand this instruction as load the accumulator, and the operand is a 16-bit address. So this instruction will load the accumulator with the data given at the 16-bit address specified in the instruction. The contents of a memory location is specified by the 16-bit address in the operands are copied to the accumulator. So the contents of the source are not altered. Example, LDA 3020. This is a misprinting here. Instruction looks like this. LDA 2034 means this is the memory location, and at this memory location, whatever data is stored, this data will be loaded in accumulator. So in this way this instruction will work. LDA then 16-bit address. Next instruction in this category is LDAX. So the contents of the destination register pair will point to the memory location. So this is the register pair. This register pair can be BC also or DE also. So we have the two options. The destination with the register pair can be a BC register pair or the DE register pair. And what it will do, this instruction will move copy the contents of the memory location pointed to by these register pair contents. It will copy the content to accumulator. So the accumulator will store the data pointed to by the BC or DE register pair. So we can say that it will copy the contents to the accumulator indirectly. That's why it is saying load accumulator indirect. The contents of either the register pair or the memory location are not altered. So the contents of the source, that is the BC or DE register pairs, are not altered in this instruction. Examples is LDAXB, means the contents of BC register pair will point to some memory location, and the data stored at that memory location will be copied to accumulator. So in this way, this instruction accomplishes its task. Another instruction in this category is STA. We can understand this instruction as store from accumulator. Means this instruction will store the data stored in the accumulator to the memory location given as the operand. So we can say that store the accumulator directly. The contents of the accumulator are copied into the memory location specified by the operand. Example STA2500H. Suppose when this instruction is executed, the contents of accumulator is 30H. So after this instruction is executed, what will happen? The memory location 2500 will be equal to 30H, means the memory location 2500 will hold the data 30H. Now, next instruction in this category is STAX. Again, this instruction will store the data available at accumulator into the memory location pointed to by the register pair given in the operand. So it will store the accumulator data indirectly. The contents of accumulator are copied into the memory location specified by the contents of register pair. Example STAXB. So what it will do? Suppose A is having the data 30H, BC register pair is having the data 3242H. Now, what it will do? It will store 32. It will store the accumulator data at this memory location. So the contents of the BC register pair will point to some memory location, and the data in accumulator will be stored in this memory location. So in this way, STAX stores the data given in the accumulator into the memory location pointed to by the register pair mentioned in the operands. Next instruction is SHLD. Operand over here is 16-bit address, and it will store the HL register directly. So the instruction can be understood as store HL register pair data directly. The contents of the register L are stored into the memory location specified by the 16-bit address. The contents of the register H are stored into the next memory location in the hierarchy, in the sequence. Means SHLD 2550H means these are the two registers, 8-bit registers H and L. The memory location given is 2550. So the L contents are stored at this location and H contents are stored at this location. So in this way, this instruction works. So the data stored in the HL register pair will be copied to the continuous two memory locations given in the operand. Next is XCHG. It will exchange the contents of HL register pair with the DE register pair. So the contents of the H are exchanged with the contents of register D, and the contents of register L are exchanged with the contents of register E. So in this way, this exchange in this instruction, the operands are not given. Yes, we can see that operands are not specified. So we can say that this is the implied addressing mode instruction. Yes. And the operands are well understood in this instruction itself. So it will exchange the contents of HL and DE only. No other register pair will be entertained in this exchange instruction. Next instruction in this category is SPHL. So it will this instruction will load the contents of HL pair into SP, stack pointer. So it will copy the HL register pair data to the stack pointer. So again, this is again implied addressing mode. No operands are mentioned and the operands are well understood in itself. So it will load the contents of HL register pair to the stack pointer. Next data transfer instruction is XTHL. The contents of L register are exchanged with the location pointed out by the contents of stack pointer. The contents of H register exchanged with the next location, that is the stack pointer plus 1. So again, this instruction will exchange the top of the stack, T stands for the top of the stack, with the HL register pair. So we know that the uppermost position of the stack will hold the H register pair contents, and the stack pointer stack pointer location will, SP location will hold the contents of L register pair. So in this way, XTHL is again implied addressing mode instruction and there is no operand given in the instruction. Next instruction in this category is PCHL. It will load the program counter with the HL contents. So HL contents will be loaded into the program counter. The contents of the register HL and R are copied into the program counter. So the contents are copied, H are placed at the higher order byte and the contents of L are placed at the lower order byte. Example is PCHL only, no operand is given. Again, this is implied addressing mode. Next instructions in this category is push register pair. This instruction will push the contents given in the register pair into the stack. So the contents of the register pair are copied onto the stack. Stack pointer is decremented and the contents of the higher order registers B, D, H and A. These are the higher order registers from the register pairs. These are copied into the stack. So SP is again decremented and the contents of the lower order registers are C, E, L and flags are copied into the stack. As you know that when we are studying the stack, as we go higher in the stack, stack pointer value decreases. Yes. So the higher order contents are at the lower level and in the next location the low order contents are stored. So as we know that when we are talking about the BC pair, this is the higher order, this is lower order. Again, when we are talking about DE register, this is higher, this is lower. Again, HL, this is the higher, this is lower pair, lower register. And again, AF, this is higher order and this is the lower order register. So in this way, the higher order register contents are stored here and in the next memory location, it is decremented and the contents of the lower order are stored at the another location. Same is the case with POP, only the difference is in the push, the contents were pushed into the stack and in the POP, contents will be taken out of the stack. So this is written this way, POP H means the contents of the stack will be popped out and will be stored in the HL register pair. Next category, next instruction is the out instruction. Out will copy the contents of the accumulator to the port given by the 8-bit port address. So the instruction here, out 78H means the contents of the accumulator will be stored at the port given by this address. And in the instruction, the contents of the port given by this port address will be stored in the accumulator. So the contents obtained at the port given by this address will be stored in the accumulator. So this is the work of in operation. That's all for the day. I have covered all the instructions of 8085 which have been categorized into the data transfer instructions. In the next lecture, we will talk about the arithmetic instructions. So thank you so much for today's lecture.